negative in sense strong negative correlation. Now next one, types of correlation. There are four types, that is positive and negative correlation. When you're talking about positive and negative correlation, it means let us consider you have the variable x and y. If your x is goes increasing, similar at the same time your y is also increasing. It means the change of direction of x and y, it is the same. It is moving in same direction. Similarly, it is also if x is increasing and y also increasing, it means it's moving in the same direction, then it's called positive correlation. But if it is exists, let us consider the x and y. X is increasing and y is x is decreasing and y is increasing, or vice versa. X is increasing and y is decreasing, then it is called negative correlation between the two variables. Linear nonlinear correlation or nonlinear correlation is called curvilinear correlation. That is, let us consider x and y is given. X is 2, 4, 6, and so on, and 3, 6, 9, so on. So you see the relationship between this x and y having the constant rate of change between the variables, then it's called linear correlation. If it does not exist, then it's called nonlinear. Partial and total correlation. When you are considering the more than two variables for the study the correlation between them, so while doing the correlation, let us consider x, y, z. We are taking the consideration of the x, y and keeping the z1 as a constant, then it's called partial correlation. But while doing the correlation, we are taken consideration of the three simultaneously, it is called total correlation. Again, next one is multiple correlation and simple correlation. When you are doing the correlation between only two variables, it is called simple correlation. But we are considering the three factors, x, y, and z variables, then it's called multiple correlation. But while doing this correlation, we have to take the relationship between x with the combined effect of the y and z. Then it is called multiple correlation. So those are the terminology already we have discussed. Now, measures of correlation, how to calculate correlation. There are two methods, that is scatter diagram method or graphic method, and another is algebraic method. This is already we discussed by plotting your x and y variables on the graph, and based on the nature of your data points, you can interpret is there positive or negative correlation, it is exist or not between two variables. But in algebraic method, it is given by Carl Pearson, and the formula for this correlation, that is R is equal to covariance of xy divided by under root of variance of x and variance of y. Okay, so this is the relationship between these two variables, and this covariance of x and y we can note it like this. And when simplification of this formula, this is most generally we are using this formula for the calculation of the correlation. But when you are dealing with the 3-digit, 4-digit numbers and calculating such correlation, it is very difficult to manage the high-digit numbers. So what we have to do, we have to just take the transformation, or we have to take the deviation of the original data set with any arbitrary constant. Let us consider we create two variables u and v. So whatever the x value you have given, we take the deviation with any arbitrary constant. So, and divide with the whatever the cost interval it is exist. So we generate the new variable u. Similarly, we have to generate the new variable y based on your original data set. So just we have to just replace this u and v instead of this x and y. So we'll get the new formula for calculation of the Pearson correlation coefficient, and it is a simpler way to making the calculations. While applying the correlation, we need to be understand the assumption which need to be considered. The first assumption, that is linearity, we need to be consider whatever the observation we are taken under consideration, it should be follow some linear distribution, and it should be have the normal distribution. Okay, there should not be any skew distribution, that is positive or negative direction. Then such kind of the things we need to be considered while applying the correlation coefficient. Now, Another most important thing while doing the correlation, that is there should be the cause and effect relationship. It means both variables, it should be related to each other. Otherwise, when you make the relationship, it called a spurious correlation. Let us consider your x is your height of the student in the class and y is the height of the plant in a field. When you are make the correlation between such, it is not it is a meaningless correlation, and it's called nonsense correlation or spurious correlation. So there must be the relationship or assumption that should be the cause and effect relationship between these two variables, and then only we can consider for the correlation coefficient. Okay. Now there are some properties we need to be considered while calculating the correlation coefficient, and those property, and based on those properties, the different questions will arise in your competitive examination. The first, like this correlation coefficient is always lies between -1 to +1. We already discussed if r is equal to +1 and r is equal to -1, it means it shows the perfect positive correlation and perfect negative correlation respectively. One more thing we need to be this most important thing about this is correlation, that is r is, that is correlation coefficient, is independent of change of origin and scale. It means whenever the data set, let us consider the data set of x and y, it is given. If you multiply this x with a, that is arbitrary constant, if you divide with a, you addition with a, you subtract with a to the x or y, your correlation will not be changed. Okay, so that's why your r is independent of change of origin and scale. That is means when you add or subtract and constant to the your original series, there is no change in value of correlation coefficient. Another thing we need to be property, it is most important, that is when x and y are two independent variables, then correlation coefficient between this x, it is always 0. It means both x and y, it should be have the linear relationship between, or cause and effect relationship between these two variables, it should be exist, then only we can make the correlation. Another thing, an important point, that is r, that is equal to geometric mean of your coefficient of regression, x on y or y on x. Okay, this is the geometric mean of this coefficient of regression. We'll discuss this coefficient of regression in next later slides. Another thing we need to be consider of the property of correlation, that is the correlation always in symmetric matter. It means if you do the correlation between x and y, it is always equal to correlation between y and x. It is called symmetric relationship between those. Now, when you are dealing with the qualitative data, we are using Carr-Pearson correlation. But when you are dealing with the qualitative data, we have to use Edward Spearman's rank correlation. Okay. So when you have the qualitative data, we have to make it into quantity, or we have to make it, or we have to give the rank to our data set based on their quality. So first of all, whatever the data set you have to make the ranking, and based on this ranking, we have proceed for the rank correlation. For calculating the rank correlation, we are using the formula, that is Rxy is equal to 1 minus 6 times summation of d square divided by n into n square minus 1, where d, it is a difference between the ranks pair of the ranks, and then we have to make the square of this difference and use in the formula, where n is your number of pair of observation we are using in data analysis. In case of the rank correlation, here also the value of r always lie between the -1 to +1, and if the value of r is equal to +1, it shows the complete agreement in the order of their rank. If it is -1, it's called the complete disagreement in order of the rank, and it is in opposite direction. So based on this rank correlation, we make the interpretation based on the value you are getting. Now, based on this r value, we have can understand these two terminologies, that is standard error of r and probable error of the r. And based on this, such kind of the question will make us in your examination. Like standard error of r, that is can be calculated with help of this formula, that is 1 minus r square divided by root of n, where r is your coefficient of correlation. Similarly, when you multiply this standard error with the factor that is 0.6745, we will get the probable error. And based on this probable error, we can make the interpretation of the correlation coefficient, it is significant or non-significant. If your relationship between this R with respect to probable error, if R is less than probable error, we can call it is non-significant. But if your R is greater than 6 times of probable error, we can say your correlation coefficient is significant. But if your R is less than 6 times of probable error, then it is difficult to interpret your result, and it is it is very small size to interpret the results, right? Now, whenever we are talking about this correlation, we must check the significance. We are already seen the based on probable error how to interpret significance of the correlation coefficient. But when you are move for the testing the hypothesis, that is your correlation is equal to 0 or it is not equal to 0, we are using T statistics for the testing the significance of correlation coefficient. So question will arise in your examination while testing the coefficient of correlation, which test it is using, that is T test, and it is let's say with n minus 2 degrees of freedom. Generally, we are considering in analysis of variance n minus 1 degrees of freedom, but testing the significance of correlation coefficient, applying the T test, we are considering the degrees of freedom n minus 2. Similarly, generally we are seeing when your data set is large, at that case, we are consider or we are shifted this test into Z distribution, and we are using this formula for testing the significance of correlation. Also, we can test the significance of correlation based on the analysis of variance technique, where we are using the F test for the testing the significance of correlation, where we are using this formula for calculation of the F statistic, and based on the F table, we make the interpretation that your correlation is significant or non-significant with n minus 2 degrees of freedom. Another most important term which exists in correlation analysis, that is coefficient of concurrent deviation. When we are not much serious about the magnitude of our variables, then we are using this concurrent deviation, and for this concurrent deviation, we are using this formula. Just see the example so you can understand well about the concurrent deviation. Let us consider you have the data set year wise of the price data, okay, and you have the data set of the demand. Now observe the data set, that is when you are in 1990 your price is 25, is goes increasing and then decreasing again increasing, so such kind of pattern is exists. Similarly in demand also, your 35 it is in 1990 and it goes decreasing increasing again decreasing and decreasing. So whatever the pattern of the price and demand, we have to assign the sign to them. If 25 is goes increasing, we are making positive sign. It is again increasing, positive sign, negative, that is decreasing, and so on. We are make the sign to our numbers. So based on these numbers, we have to make the product of those signs, that is positive sign and negative sign, will get the negative. Multiplication of this positive into negative is equal to negative, positive into positive, positive, negative into negative, that is positive. So based on those pairs, we have to understand how many pairs of deviation. Here in the problem there are number of 7 pairs, and how many numbers of the positive signs here is are 2. So those value we have to consider in the formula, and you can calculate this the relationship between these two variables. Now next, so all this about your correlation coefficient. Now next we move further for the simple linear regression equation. This is regression. It measures the average relationship between two or more variables in terms of original unit. Okay, and it shows the functional relationship between dependent variable y and independent variable x and x or x, and it is called a regression equation. There are again three types: multiple or simple regression, linear, non-linear regression, and total and partial correlation. When you are talking about the y and x, that is y is your dependent variable and x is your independent variable, and you are considering only two variables simultaneously, it is called simple correlation. But if you are considering x1, x2, x3, and so on, that means you are more number of independent variables, then it's called multiple regression analysis. Linear and non-linear regression analysis. If you see the relationship between x, that is independent variable, and y, it is your dependent variable, and you make the ratio between your dependent and independent variable, it is a constant, then it is called linear regression. If the ratio between this it is unconstant or it is not constant, then it's called non-linear regression. Total and partial correlation. It means when you are considering the all the dependent and independent factors simultaneously, it is called total regression. But while making the regression, some of the factor, let us consider, we are removing it or making the constant, then this is called partial regression. Those are the terminologies we just discussed. Now, in linear regression, the basic equation for linear regression, that is y is equal to a plus by x plus e, that is error term, where a is your intercept, by x, that is coefficient of regression, y on x is your independent variable, e is your error, and it is always distributed to the normal distribution with mean 0 and the variance is sigma square. Let us consider x is your independent factor, y is your dependent factors, and you make the regression line where this line which intersect your y, the point it is called intersect. The your line which intersect your y-axis, the point it is called intercept. The ratio between your observed variable and whatever you are estimated based on this line, this is called error. And the line which is you are fitted with help of the linear regression, that is y is equal to a plus bx. Now, while fitting this regression line, we have to estimate the value of a and b, and it can be estimated by applying the method of least square. Okay, so applying the least square, we have to make the method, or we have to minimize the error by using this condition. That is means we have to make the minimizing the square of the error, sum of the square of the error with respect to other variable. That is summation of the ei square is equal to summation of your y is your dependent variable, a is your intercept, byx, that is your coefficient of regression, and x is variable, and we have to make the square of this. We have to, while we have, how we can minimize it, we have to minimize with respect to taking the differentiation, partial differentiation with respect to your a and with respect to your b. So while, and we have to equate it with equal to 0. So we'll get the some equation, and when you solve those equation, we are directly get these formulas for calculating the estimating the uh, constants of a and b. This is formula for the estimating the b, and this is formula for estimating the a. Once you get the value of a and b, just we have to put in the equation, that is called regression equation. Now there is some relationship between your coefficient of regression with respect to their correlation value. Let us consider byx, that is the value of coefficient of regression y on x is always equal to r into standard deviation of the y divided by standard deviation of the x. Okay, this is the relationship between those values. Now see the this graph in which you see while fitting the regression line, this is the data point, those rounds are the data point, and your regression line goes central from the this points, and one of the point you see this is outside the whole data set, it is called outlier. Okay, and when you fit this regression line, you will get the value of r, and here r is showing 0.77. It means it shows the 77% variation in your y. It is because of your these independent factors or independent x variable. Okay, so this is about the your regression line when we are fitting in the or the data set in the graphical form of view. While fitting the regression line, you must have to consider some of the assumption while applying the linear regression. The first assumption, that is relationship between your variable, it should be linear. Then When you feed the regression line, the whatever the residual we get, it should have the same variance. And when you are talking about the same variance of the error, it's called homoscedasticity. Then another assumption, that is residual, it should be independent in nature. That means it is not correlated to each other. So your it means there should not be multicollinearity in your independent factors. Then your residual, it should be follow the normal distribution. So this most important assumption, it need to be followed while applying the linear regression. There are some properties we need to be considered while using this regression analysis. So first property, that is regression coefficient must have the same sign, either it is positive or it is negative. This property we already checked. Just a minute. Hello. Sorry to uh, okay, it is important. It was an important call. Okay. Anyway, we continue. So another properties of regression coefficient, that is correlation coefficient will have the same sign that of the regression. It means if correlation coefficient is your negative, your regression coefficient also negative. Another thing, when you take the arithmetic mean of this regression coefficient x and y and x, it is always equal and greater than the coefficient of correlation. That is means when you take the arithmetic mean of these two, it is always greater than equal to r. Now we are talking about the bxy. You first understand what is bxy. Bxy, it means y is equal to a plus bxy. Sorry, x is equal to this one. When you are applying such kind of the relationship, when your x is your dependent and y is your independent, you are using bxy. But when we are talking about byx, that means y is equal to a plus byxx. That is means y is your dependent variable and x is your independent variable. That means bxy and by on x. Okay. When you are talking about the correlation, if r is equal to 0, it means your line of regression, it should be perpendicular to each other. If r is equal to plus 1, then both lines are parallel to each other. And when you are considering the angle between these two regression lines, then we are using this formula for the making the relationship between or understand the degree of angle between two regression lines. So those are the property we need to be considered while studying the regression analysis. And based on this property, it may be arise number of questions for the examination. Similar way, for testing the significance of correlation, there should be how to test the significance of the coefficient of regression. Here also we are using the t-test for significance of the correlation, significance of the coefficient of the regression. Those formula you have to take. Here also you have to take the degrees of freedom n minus 2. Whereas those are the formulas for calculating this one. Another method for testing the significance of the regression coefficient, we are using the analysis of variance. We fit the regression. Whenever we go for the fitting the regression line in Excel or any software, we are getting this ANOVA table. In this ANOVA table, based on those calculated value of the f, that is v1 divided by v2, that means the regression mean sum of square divided by the error sum of square, will get the value of f, and we will have to consider the table value. And if your calculated f is more than your tabulated value, your coefficient of regression is significant, otherwise it's not significant. Now we proceed further. When you are talking about the simple correlation or simple regression, we are considering only two variables, that is x and y. But when you are talking about the multiple correlation, let us consider there are the three variables x1, x2, and x3, and we have to make the relationship between these variables. What we have to do, we have to take the correlation between x and 2. we have to take the correlation between x and the joint effect of x2 and x3. Then it is called multiple correlation, and it is calculated with help of this formula, that is R1.23 is equal to covariance of this one. It means the correlation between this R1 with joint effect of 2 and 3. Similar way, we can make the simplification of this formula with help of this formula. Okay, so keep in mind, while if you in examination the value of R12, R21 or R23, it is already given. So based on those value, you can calculate this multiple correlation coefficient. So similarly, when we are talking about the R2.13 or R3.12, we just replace this combination, or we make the formula for those. When you are talking about the multiple correlation, and if you make it square, when you make it square, it is called coefficient of multiple determination, and it's explain the proportion of the variation of the your dependent variable, let us consider x1, which explain the your independent variable 2 and 3. Let us consider if r is 64, it means it should explain the 64% variation in your dependent variable. It is because of your independent factor, and remaining percentage, it is because of other factors. When you take the difference between the 1 minus r square, it is called coefficient of non-determination. The range of coefficient of multiple correlation, the range of multiple correlation coefficient is 0 to 1. It is 0 to 1. Now, those are the properties we need consider while studying the multiple correlation coefficient. The range always lies 0 to 1. Okay. Now, some of the property we take under consideration while considering the multiple correlation coefficient. If the value is 0, that means your dependent variable is uncorrelated with other independent variables, right? When you are considering this multiple correlation coefficient, it is always greater than your individual correlation coefficient. It is always greater than your independent correlation, and those are the listed number of properties of the multiple correlation coefficient. Now, here also we have to test the significance of this multiple correlation coefficient. We are seen for the simple correlation coefficient, we are using the t-test, but while considering the multiple correlation coefficient, we are using f-test for the testing the significance of correlation, where degrees of freedom we have to consider, that is k comma n minus k minus 1, where k is the number of independent variable which consider while calculating the multiple correlation coefficient. When you compare both value of or two value of multiple correlation coefficient, then also we have to use f statistic or f test for the testing the significance of correlation coefficient. We have seen the multiple correlation coefficient. Now, what is a partial correlation coefficient? Let us consider the three variables x1, x2, and x3. And when you take the relationship between this x1 and x2 while keeping this x3 as a constant, then or we can excluding this x3, then it's called partial correlation coefficient. But in case of multiple correlation, what we are doing, we are making the correlation between x1 taking the joint effect of x2 and x3. But in case of partial correlation coefficient, we have to make the correlation between x1 and x2 keeping this one constant. That's why it's called partial correlation coefficient, and it is denoted with small r 1 2.3. It means the correlation between 1 and 2 keeping this third one is constant, and the formula it become like this. Okay, in partial correlation coefficient also we have to take consider that it is ranges between -1 to +1, similar as a simple correlation coefficient. One more thing we need to be keep in mind, that is if your correlation coefficient is 0, that means your relationship between first and second variable, it is always equal to the product of correlation between first and third variable and product of second and third variable. Okay, so this is called partial correlation coefficient. But when you are taking the relationship between multiple correlation coefficient and partial correlation coefficient, it can be expressed in form of this formula. So those formulas, this relationship, keep in mind in examination point of view. Here also we have to test the significance of the partial correlation coefficient, and here we are using t-test. So keep in mind the t-test, it is used for the testing the significance of partial correlation coefficient. Now we proceed further the multiple regression analysis. In multiple simple regression analysis, we are taking the y is the dependent variable and x is the independent factors. But in case of multiple regression analysis, we have to use more than two or more than one variable as an independent factor, then it's called multiple regression analysis. Let us consider there are two independent factors, then equation it become like this. If there are more than two independent factors, the regression equation is like this. Okay, in which your y is your dependent variable, beta 0 that is your constant, or it can called is intercept, beta 1, beta 2 it's called a partial regression coefficient, x1, x2 and so on, those are called independent variables. Okay, and it is error which is always follow the normal distribution with mean 0 and variance is sigma square. Okay, again the range of this correlation partial regression coefficient, it is lies between -1 to -infinity to +1. So those ranges in the correlation studies in multiple regression, simple regression, multiple correlation, multiple correlation, partial correlation, whatever the range are exist or we are study, keep in mind such kind of the question will ask in your examination. So while fitting this multiple regression line, we have to make some matrix calculation. Okay, and in that we have to first arrange the data set according to our fitting the regression line. Let us consider there are the number of response of y1 to yn and the corresponding explanatory variable or independent variable it is given. That is, let us consider y is affected or response variable, it is because of those independent factor, y2 because of those independent factor. While solving this or fitting this regression equation, we have to find out the constant beta 0, beta 1, beta 2, beta k and so on. So we have to use this matrix multiplication. So we rearrange our data set like this. We can call it as y variable. It is a matrix of the x. This is a beta and this is a error term. Okay, and we have to solve those matrix multiplication. We will get the values of beta 1, beta 2 and beta k. If you are talking about only two variables simultaneously in the multiple regression analysis, we can use this direct formula for calculating the beta 1 and beta 2, that is coefficient of regression, and intercept, that is beta 0 or a, with help of those formula. In terms of the correlation coefficient, also we can estimate the value of beta 1, beta 2 with help of this formula. So keeping this formula in mind while estimating the parameter intercept in the multiple regression coefficient. Here also we have to take some assumption under consideration while applying the multiple regression analysis. In that, we should have the proper specification of the multiple regression. There should be, we must assume the linearity in the data set. Our error term, it should be normally distributed. It should have the common variance, and there should not be multipolarity in the data set. Your error variance should be constant, that is homoscedasticity. Whatever we are assumption we are discussed in simple regression analysis, same assumption we have to follow in multiple regression analysis. Now, nonlinear regression, it is another term which is need to be important while studying the regression. Okay, in regression analysis, when you are dependent variables showing the nonlinear function, okay, then we are using this nonlinear regression, and this is exist because of when you are transformation on the x, like x transformation, we are taking the x square or root of x, inverse of x, or we are using the quadratic equation beta 1 plus beta 1 x1 plus beta 2 x1 cube, that is quadratic equation. If you proceed further, then it's called cubic equation. Likewise, then power model, these are the nonlinear regression when y is equal to a plus x raised to b, b is the power of your equation. Okay, exponential function, y is equal to a b raised to x, that is your exponential function, or y is equal to a e raised to bx, that is your exponential function. So while applying this nonlinear regression, first of all, we have to transform those nonlinear regression into the linear form. Let us consider for the more power model, we make the transformation that is logarithmic transformation. So we're making this in linear form. So this log of y we consider as the y is equal to a plus b x. So this is our simple linear regression, and we have to apply the same thing or same formulation calculation on the simple regression analysis. While studying the nonlinear regression, we have to again consider some points. That is, while we are making the transformation of the independent factors, we have to consider what changes are occurred. Let us consider if you are making the square transformation, it means it shows the increasing rate with respect to your x and y. It's showing the increasing with increasing rate. If you make the square root, it means in increasing with decreasing rate. If you take the inverse of your variable, it is decreasing with decreasing rate. Okay. So similarly, while talking about the quadratic equation, whatever the data set we have, and we fit the quadratic equation, if the value of beta 2, it is positive, is showing the shape of the curve like a convex. And when you see the value of the beta is negative, it show the concave. Similarly, the power model, if you consider the value of this beta, if it is more than 1, it is show the increasing with increasing rate. If your value lies between 0 to 1, it's increasing with decreasing rate. If your value of beta is less than 0, it is decreasing with decreasing rate. So such kind of things we need to be keep in mind in exam point of view, what kind of the changes are occur when you are applying the nonlinear regression. Now important point about the dummy variable. Okay, so we are study the simple correlation, simple regression, multiple correlation, partial correlation, multiple regression, now then nonlinear regression. Okay, now we proceed further for the dummy variable. See, in the most of the linear regression, we are dealing with the quantitative variables. Okay, so we have the let us consider the we have to take the relationship between the yield with respect to different weather variables. So these different weather variables are the quantitative variables. Y is your quantitative variable. But when you are comes under the we are talking about the categorical variable as a predictor or response variable or independent factors, then we have to use this dummy variable. Let us consider some of the example, that is eye color. In eye color, there are different colors are there: blue color, green color, brown color. Those are the categorical data. So we have to make such this categorical data into quantitative data first. Like let us consider we are talking about the gender. There are only two categories, male and female. Okay, or if another category you can include, that is transgender. Okay, so these are again three categories are there: marital status, married, single, or divorce. So such categories we taken as a predictor or independent factor while applying the linear regression. So while dealing with such kind of the data, we have to use we have to make the subgroup based on those characteristics. And whenever we are applying the this dummy variable, we are creating the k minus 1 number of the groups. That is where the k is the number of values that categorize the value. It means let us consider the eye color. There are three categories: one, blue, green, and brown. That means we consider is a 0, 1, and 2. We are making this. Okay. So whenever you have make the regression line, it is always taking the consideration only two groups. Okay. So that means k minus 1 dummy variable need to be considered while regression analysis. We've seen the one example. Let us consider this is the income, this is the age of the person, and the marital status. There are three marital status: single, married, and divorce. Okay. So what we have to do, we have to make some arrangement. That is, let us consider single, it is equal to 0, married is equal to 1, or divorce is equal to 2. We are making the category 0, 1, 2. There are three categories, right? There are three categories. But when we are making the dummy variable in the regression line, it is considering k minus 1 variable, that is only married and divorce. Okay. So married, we are considering 1, and divorce, we are considering the 2. But before proceed to the regression analysis, what we have to do, we have to create the dummy variable. So our first variable, that is single. If your variable it is single, it means if it is single, we are taking the 1. If it is not single, then it is 0. That means this kind of the coding we have to do. Again, we have to make another variable, that is married. If not married, then 0. Then duos, if duos is there, then 1. If duos is not there, then 0. So such kind of things we have to make with our marital status into 3 subgroups, that is single, married, and duos. But when you're making the regression analysis, it is considering out of these 3 only 2 groups. Let us consider in here both are the 0. It means your category of this 23 age both are 0. It means it is not married, it is a duos. It means automatically it is a single. It is a single. So this group, third group, is auto defined. Why we are doing this? But let us consider, if you enter in this, then multicollinearity, it exists in your data set, and the assumption of linear regression is violated. So therefore, k minus 1, that is dummy variable, considered in the linear regression line. Understand? This is about the linear dummy variable while doing the linear regression analysis. Okay. There are some test steps we have to follow for the dummy variable. First of all, we have to run the separate equation for the each group. Like, let us consider there is a we have to make the relationship between age and the marital status. Then we have to run the age with singular, age with married, age with divorce. We have to run separate equation for the each subgroup category, substituting the dummy variable. Then we have to find the difference between these groups and again their equation. This procedure we have to follow while applying the dummy variable. Let us consider the equation y is equal to beta 0 b1 z1 e, where this one is your categorical value. Let us consider we are taking the group 0, we make the run the regression equation. When we are taking the z is equal to 1, we again make the run the regression equation, and whatever we are getting the equation, we make the difference between these two, and we have to proceed for the further analysis. Understand? Now, next point about the factor analysis. In factor analysis, we have to keep in mind those are the data reduction techniques. Factor analysis, cluster analysis, discriminant function analysis, those are the data reduction function. Most of this in social science study, we are considering or we are making the questionnaires and making the survey. And there are lot of observation variables, and we are response are available. Let us consider I make the survey and getting the 500 uh, my object or respondents are there, 500 respondents are there, and while dealing with this 500 respondents, I have to make them in some point of the classes or some point of the groups or some of the based on some parameter or some variables. Then it's called data reduction technique. In that, if you are talking about the factor analysis, it is a way to make the mass of the data or sinking into the smaller data set. Okay, so we can easily, it can be manageable or it can be understandable. We have to understand the what kind of the pattern it is data is following. Okay, what kind of the hidden pattern exists in your data set? Is it overlapping to each other or not? Okay, is there exist a number of patterns or number of characteristics in particular same pattern is exist or not? So we have to understand first data set, and based on this we have to make the different groups or different sets of the data set with help of the factor analysis. This factor analysis also create the set of variables for the similar item, those having the same characteristics, same pattern. We have to make some group of the same set of the variables, and this factor analysis is most useful for the complex data set in the study of the psychological studies, socioeconomic studies, status, such kind of concept. It is generally used in the such case of the study. When you're talking about the factor, it means it is about the observed variable. Okay, which showing the similar response pattern. Okay, when you are talking about the factor, it's showing the similar response pattern, and it is associated with the some hidden factor. This hidden factors or hidden variable, it is called latent variable. Okay, we cannot estimate or cannot understand this pattern, so it is also called compounding variable, and it cannot be measured directly. Okay, so whatever the factors we have to observe, we have to just a minute. Whatever the factors we have to understand directly. Sorry for disturbance. Okay, so when you're talking about the factor analysis, one factor is its observed variable, and the factor which is associated with the hidden factor or latent variable, which cannot be measured directly, that is called a compound variable, which taken under consideration in the factor analysis. Also, factors are can be listed based on their factor loading. It means how much variation the particular data set or data is explained, or what is the variation of the particular factors which associate with your observed variable. It is called factor loading. And based on this factor loading, there are again two kind of the types are explained here, that is exploratory factor analysis and confirmatory factor analysis. When you are talking about the your data set, or you have the already have the idea about the structure, if you are sorry, if you don't have any idea about the structure of the data set, this is a very huge and complex data set. At that case, we have to use exploratory factor analysis, where we don't know how many dimensions are there, how many, what kind of the nature of the data set is available. Such data set or such factor analysis, it is conducted based on exploratory factor analysis. But when you are talking about the data which have the already have the idea about the structure and what dimension are exist or set of variables it is in your data set, then we use the confirmatory factor analysis. If you want more details about this, the link is given in presentation. You go or more detail about those factor analysis. Okay, now next one is cluster analysis. Now first of all, proceed to the further. It is a simple data reduction technique. We can divide our data set in different small groups having this common characteristic. Let us consider this diagram. In this diagram, you see the different colors combination or different color groups are gathered together. Okay, this show there are the three clusters which having the common characteristic. Let us consider the clustering is a statistic which refer the data is gathered or cluster based on the different factors like age, household, income, or education level. Let us consider those have the having the common age, those factors having the common income, those factors having the common level of the education. So those factors are gathered together. This is called a cluster analysis. It's called a classification of this thing. Okay, this classification of this cluster can be factor based on those two methods, that is distance based clustering and conceptual clustering. When you are talking about the distance based clustering, in which the items are sorted based on their proximity or based on their how much distance between these different data sets. Let us consider the example, the cancer cases are there. We cluster them together based on their geographical location. The cancer cases in the Maharashtra, cases in the Gujarat, cancer cases in the UP. So such classification or this clustering, it is based on the distance or based on the geographical location. Therefore, it's called distance based clustering. When we are talking about the conceptual clustering, it means it is group the factor based on some having the common factors. Let us consider the cancer cluster could be grouped based on the people who work in manufacturing. Okay, so based on the those work or those people, those are working in manufacturing, or those person, those are working in the academic section. The based on this, when you are making the clustering based on some concept, some based on some characteristic, then it's called conceptual clustering. Now there are different types of clustering. First one is exclusive clustering, fuzzy clustering, overlapping clustering, hierarchical clustering, probabilistic clustering, and the word method which are using for the clustering. So those are the types of the clustering. In the clustering, when you are talking about exclusive clustering, in which each atom can only belong to the single cluster. Okay, there are only belong to the only one cluster, and it cannot be group into the another cluster. It means, let us consider this is your group. So it means it is not merged with any others. That's why it's called exclusive country. It's not it means it's excluding the other things which are not related to particular group. Fuzzy clustering, the data point assign the probability belong to the one or more cluster. It means whenever you're doing the clustering, we have to take the consideration of the assign some kind of the randomization process or probability for the selection or making the clustering. It's called a fuzzy clustering. Then overlapping clustering, it means one of the or two atoms which belong to the one cluster, it's also present in the another cluster. It means there are a subset of those of common. Okay, such kind of the clustering is called overlapping clustering. Then hierarchical clustering. Hierarchical clustering, it means your data set, it is divided or it is classified or clustered based on some kind of the hierarchy. Let us consider one of the thing. Let us consider you are making the data set in the for the district, then you move for the talukas. Okay, and this talukas, then we move for the villages. So such kind of the clustering is called hierarchical clustering, and such kind of the graph which are getting, it's called dendrograph graph. Okay, so this hierarchical clustering with dendrograph, you are make the classification of your data or make the reduction or remove the complexity of your data set. In this hierarchical clustering, the pair of cluster is joined based on the similarities and giving one less cluster, and this process is repeated till you are not make all clustering in this group. Okay, another thing that is probability clustering, the data cluster using algorithm which is connect to item with the distance and densities. This usually performed by the computer. So all those happening probability clustering, we need to prepare the algorithm, and such kind of the clustering, it is generally you are just new term you are heard about the machine learning. The machine learning, it is one of the tool which you are make the data set in the form of the cluster or simplify with help of the probabilistic clustering. This is one of the example for the probabilistic clustering. Another method, that is word method, it is used for the clustering. It uses by minimizing the variance in each step to the relatively small and resize the cluster. It means whenever you are making the cluster in your whole data set or large data set, it take care of the minimize the variation or minimize the variation between the each group, and again it recluster for the based on this minimum variance, and this is given by the bars. Okay, so those are the different types of the cluster. So we have seen the cluster analysis, factor analysis. Now we proceed for the discriminant analysis. It is also called linear discriminant analysis. This is another method of the data reduction techniques. In statistics, if you understand pattern of recognition, the machine learning things, and linear discriminant analysis, all those together, it is called canonical variate analysis. Okay, in canonical variate analysis, we have to understand linear discriminant analysis. Okay, in which we have to study the differences between the different objects based on our data set. We have to sorting our data set based on the linear combination with respect to some feature characteristic of the classes, and we make it for the, or simply we can make it discriminate our data set in different groups. Okay, so generally whenever we are using discriminant analysis, we generate the scores, and the scores that separate an object from one particular class to next and express as a linear combination of the different explanatory variable, and that can be optimally separate the our classes which having the we uh, already discussed or already made. So this is help in the, with help of this discriminant analysis, we make the group in different classes. This linear discriminant analysis, it is a linear transformation of the technique that commonly use dimension reduction. Okay, it perform dimensional reduction by preserving much of the our classes in discriminatory information as possible. It is a supervised and computer in direction, and it is a linear transformation. It is a linear transformation of the technique that commonly use dimension reduction. Okay, it perform dimensional reduction by preserving much of the our classes in discriminatory information as possible. It is a supervised and computer in direction, and it is a linear transformation of the technique that commonly use dimension reduction. that will be represent the axis that maximum the separation of the between the different classes. Let us consider the graph where the A and B, those are the distance function which separated your groups X and X2 data set, and you make the different classes based on the discriminant function analysis. Now there are some steps we need to be follow while making the discriminant analysis. First steps, we have to form the groups. Based on this group, we have to estimate the scores, that is discriminant function. Once you make the discriminant function, we determine the significance of this function and its variable. Then based on this function, we interpret it and then proceed for the performing the classification, and we have to perform the validation of the what we have to make the classes based on discriminant function. And this is a flowchart for the doing discriminant function analysis. Then we have seen the cluster analysis also making the classes, discriminant analysis also making the group of classes. Then what is the difference between this? The cluster analysis is a very similar to discriminant analysis, but both method involved for the separation of the group. However, the cluster analysis is way to identify the group, but the discriminant analysis is require you to know the group before you begin the analysis, right? This is the main difference between the cluster analysis. For example, let us say the group of psychiatric patients with abnormal behavior, in which the cluster analysis could help you find the distinct group, like patient with history of abuse, those have the PTSD, or those experiencing the hallucination. Such kind of the terminologies we generally use in psychiatric patient. I also not known those meaning, but we have to make the cluster based on their whatever the patient's history. Okay, but if you run the discriminant analysis for the same group of the people, we must know, or we must diagnose before you start this discriminant analysis. You have to make them into the different groups. So cluster analysis provide the basis for the discriminant analysis. This is the basic difference between cluster analysis and discriminant analysis. So it is all about the data reduction techniques and the correlation and regression analysis. Thank you very much. If anyone have the doubt, you can ask. Otherwise, we stop. Hello. Hello. Actually, your voice is not audible. Can you make the text in the chat box?
Hello.
Hello. Praveen, are you Praveen?
Hello.
Hello. Yes, yes.
Am I audible, sir?
What is the difference
Yes.
between Spearman correlation and Carr Pearson? Okay.
Yes, sir. Yes, sir.
Okay. Okay.
Yes, sir.
So see, when you are talking about
Yeah,
the
I think there has network.
yes, see, in the yesterday also there was a network issue. You have to work on, because you are running the this national training for your students. So the connectivity should be strong, right? Because otherwise, different this issue or raise, right? Okay, the difference between the Spearman correlation and Carr Pearson, it is very simple. See, when you are talking about the qualitative data and quantitative data, so when you are talking about the quantitative data, we have to proceed for the Carr Pearson. But when you are talking about the qualitative data, we are using Spearman correlation. Okay, the Spearman correlation, where it is considering the ranks. Okay, and based on this ranking, we make the relationship between different variables. So this is a basic difference between these two. And the range of those correlation, it is the same, that is -1 to +1. Okay. Anything else? Please, you can put your question in chat box. I'm seeing your chat box. See, there are a lot of time to discuss any point of view. So, when you are talking about this ARS and or NET examination, there are very little question come from the statistics, right? You say your major group is social science, and generally in the economics, the statistic run simultaneously as a sister branch. So, while studying the economics, you should have the knowledge about your this statistics subject, right? So while studying this subject related to correlation and regression or this data reduction techniques, you must understand the basic concept about these things, like the range of this correlation, regression, then what formula we are using, what kind of the interpretation based on the values, like when the value is minus 0.25, so what will be the interpretation? Okay, if such kind of the variable is given to you, then what kind of the interpretation is there? If the R square value is you are giving 0.76, then what will be the interpretation? So such basic thing we need to be understand. The another question come from the Anjali, that is what is dummy variable? Dummy variable trap. Okay, the dummy variable trap, it is about the limitation. Okay, trap, it means when you use this, we have seen the one example in our today's presentation, that is there are we are making the three groups: single, married, and diverse. Okay, there are three groups, right? Out of these three groups, when you run the regression line, these are considering only two groups. Okay, that means k minus 1 groups. But if you considering these three groups simultaneously, then what happen? Your third variable, it make the multichronality in the independent factors, and it's violate your assumption. And this is called trap of dummy variable. Okay, and that's why you are using, and we can remove this trap with help of k minus 1 dummy variable. Understand? Anything else? So Praveen, you ask the other participant, is there any questions? Otherwise, we can stop you. I'm seeing the chat box. Is there any question? They can put in chat box also. Hello.
Yeah, okay, sir. Thank you so much.
Hello, Praveen. Are you Praveen, right?
Oh,
Hello.
okay, sir.
Okay, then thank you very much. I am not audible to you.
Yes, sir. I'm audible, sir.
How you are audible? But you must work on this your internet issue, right? Because you are running very good this training for the students. So you should be have to more audible than the participant or any speaker, right? Thank you very much. And I one of the in chat box asking for the sharing the presentation. I definitely share my presentation with you. Okay. Thank you very much.
Thank you, sir.
Thank you.